Hello guys, how's it going? Today we have the integral of 0 to 1, 2 over 2x squared plus 3x plus 1. Can't do long division here. This is a partial fraction decomposition problem. So the first thing you want to do is you want to get the denominator factored. So to factor the denominator you have to use factor by grouping, and that's where we're going to write 2x squared and then split up the 3x into 2x plus x plus 1. And then we can factor out 2x. Then we'll have x plus 1 plus x plus 1 equal to 0. So now this simplifies to, can also be written as 2x plus 1 times x plus 1 is equal to 0. So now we're going to use these two linear factors. We're going to use those in our linear factors when we write this as a over 2x plus 1 plus b over x plus 1. Alright, we gotta solve for the coefficients a and b right here. All we have to do is multiply top and bottom, or not top and bottom, but the equation by each other's denominators. So we'll be multiplying by, let me fix this real quick. We're going to be multiplying by x plus 1 and 2x plus 1. And again, this is just to get the common denominator we need. So for this one, 2x plus 1 and the x plus 1 will cancel. You'll just have a times x plus 1 and then plus b 2x plus 1, and that's equal to the numerator, which is 2. Okay. Alright, so I'm going to solve for a and b using substitution. There's multiple ways to do it, but I'm picking what I think is the easiest. So x is equal to negative 1. So you have a times 0 plus b, which is negative 2, will be negative 1. B is equal to 2. So multiply by negative 1, and you have b is equal to negative 2. And then let me scroll down. Okay. Now I'm going to use the substitution. X is equal to negative 1/2 to solve for b. When I do that, I get a over 2, and then b goes to 0 now, is equal to 2. Multiply by 2 to solve for a, and I get a equals 4. Alright, so now we're ready to plug that back into Alright, we're ready to plug that back into what we found in the beginning, the partial fractions. Actually, okay. Alright. So this becomes a is 4. So we have 4 over 2x plus 1 dx plus b, which is negative 2 integral from negative, I already have the negative 2 out front, so all I have to put is 1 over x plus 1. is equal to, so if we can use substitution to solve these ones. We can make u equal 2x plus 1 here, and u equal to x plus 1 here. So it becomes, before we'll go out front, and then we'll have 1 over u du. So we take du here, the derivative, and we get 2 dx. So when we plug that in, the dx into it, you get negative 2 over 2, and that's going to be, 4 over 2, and that'll be positive 2. And this 4 right here should actually be, that should be 2. Okay, I'm going to move back up top to right. Alright, here's the answer to the problem. It's 2 ln of 2x plus 1 minus 2 ln of x plus 1. Alright. I didn't need to write this line so obviously right here. That is 2 ln x plus 1 evaluated from 1 to 0. When we put in 1, we get 2 ln, 2 times 1, which is 3, so 2 ln 3. And then minus 2 ln 2. And then when you put 0 in, you get 2 ln of 1, which is 0, so we can ignore. Minus 2 ln, and for this other term, you get 0. Or sorry, 1. But ln of 1 is 0, so that'll also be 0. So that means for our answer so far, this is what we have. 2 ln 3 minus ln 2. So since they have the same coefficient out front, you can use logarithmic simplification. So you have ln 3 minus ln 2, you can just rewrite that as 2 ln 3 over 2. And that's your answer. I'll box it in. Okay, there you go. Have a good day.